Hello, we are the EngiNerds, number 51243, and this is our design process program. I am Grace Miller.
And I'm Karthik Jain.
I'm Brandon Davis.
And I'm Fletcher Farwell.
And I'm Mitch Ross.
This is our program, or these are our programs. First is a gyro movement program. Our gyro movement program combines all our custom My blocks, allowing us to move our robot with customized commands that help our robot to move in a straight line with the gyro, make precise turns, and reposition the attachments that we mount.
This is our gyro turn My block. The gyro turn program helps the robot turn to a given angle precisely. Our inputs include angle and direction. The My block first resets and calibrates the gyro. It then turns both wheels at the same time, at the same speed, in opposite directions until it meets the target angle. Finally, it turns both motors at a slower speed so that it meets the exact target angle.
The gyro straight My block. The gyro straight My block moves the robot straight. It uses the gyro to keep the angle at 0. Inputs include number of rotations, the direction, and the speed.
The attachment calibration My block. So this My block resets the position of our attachments. And it does this by using a touch sensor to sense when the attachment is at its home position. Inputs include offset, speed, and direction. So offset is how far the motor runs after it's hit the touch sensor, and the speed is how fast it goes, and the direction is whether it goes up or down.
Robot design. The LD CAD mode with 3D design our robot and a software called LD CAD so that we could have a virtual reference of our robot.
This is our robot sign. Our robot is a box robot. We have 3 motors, 1 gyroscope, and 1 touch sensor. Our robot has 2 large wheels in the front and 2 caster wheels in the back. The caster wheels helps the robot turn smoothly.
Attachment mount. The attachment mount is located in the front of our robot. This is where we mount all of our attachments. The attachment mount is made up of square beams to safely secure the attachments. It uses gears to drive the attachments.
Weight problems. A major issue we had with the robot was its unbalanced weight. With heavier attachments, our robot tended to tilt forward, and because of that, we couldn't complete missions properly. To fix this issue, we added weight to the back of the robot to balance it out. That's what the arrows are pointing to.
These are our attachments. The first attachment is the elephant trunk. The elephant trunk moves linearly. It does the basketball mission, the slide mission, and the Boca mission. It has a touch sensor on the back used for calibrating.
This is the spinner attachment. Our spinner attachment is used for a treadmill mission. It uses several 24-tooth gears to spin a small Lego wheel. We add a Lego rubber band onto the wheel to increase its traction.
Thanks for watching.